Bonjour à tous. Bonjour. Du coup, aujourd'hui, on est là pour le Basecamp Starknet. Donc, c'est l'occasion de présenter l'écosystème Starknet à 42. Et ensuite, du coup, ça va durer de mardi à vendredi, où pendant 2 heures, de 17h à 19h, vous allez avoir des présentations de Starknet, des cours pour apprendre à coder en Cairo. Voilà. L'objectif, c'est que du coup, on garde un peu la même mentalité qu'à 42 avec le peer learning. Donc du coup, ceux qui n'ont pas forcément d'ordinateur, vous pourrez partager vos ordinateurs en groupe et vous entraider. Donc rapidement, moi je vous représente 42 blockchains parce que j'imagine qu'il y a pas mal de nouveaux à 42. Donc je vous laisse le QR code juste ici. Vous avez les différents télégrammes de 42. Il y a de Starknet, pardon. Il y a un groupe Telegram qui s'appelle Star 42 et c'est tous les élèves de la communauté 42 qui sont intéressés par Starknet. Donc ça peut être assez intéressant. Il y a aussi le Discord de 42 blockchains. Si vous n'êtes pas déjà dessus, allez-y. C'est là où on met toutes les annonces des événements. Et d'ailleurs, on a réussi à obtenir des billets pour ETHCC. Donc pour ceux qui ne connaissent pas, c'est un des plus gros événements blockchain dans le monde. D'habitude, ça se tient à Paris. Cette année, c'est à Bruxelles. Donc on partage un Airbnb. S'il y a des gens qui aimeraient venir ou obtenir des billets, n'hésitez pas à me contacter. Et aussi, je vous annonce qu'on va bientôt faire du merch. Donc pour ceux que ça intéresse, voilà, ce sera l'occasion de porter fièrement le logo 42 Blockchain. Il y aura d'autres designs, d'autres couleurs. Si d'ailleurs, parmi vous, il y en a qui ont des talents en graphisme ou qui connaissent quelqu'un, ce sera avec plaisir. Voilà, je vous laisse rapidement le QR code. Et je vais laisser la parole à Elie, qui est président du coup de Starknet France. Et voilà. Merci beaucoup.
Bonjour à tous. Ça marche mieux comme ça. Ok, très bien. Alors, merci à tous. Merci Wilfried. Ok, alors là, je parle français, mais en principe, le bootcamp est en anglais, donc je vais essayer de switch tout de suite en anglais. Okay, so let's get started from now. So I'm very pleased to meet you. I'm super excited to. So I'm Luthing. I'm the lead of Starknet France. So we are the largest community of developers on Starknet worldwide. So we are the largest in the world. It's pretty exciting. We do a lot of things. And I first would like to also to thanks Wilfried and on this partnership, because that's a great partnership, and we're going to do a lot of those in the future. So yeah, so super excited to have this Starknet bootcamp, 42 Starknet Basecamp, which is a pretty exciting event for us. And so yeah, so thanks to Wilfried, it's going to be exciting. And yeah, let's get started. So again, we are the largest community of developers on Starknet worldwide. We have over 1,000 members so far, so that's pretty huge. I'm not sure how many of you are already super familiar with blockchain, but trust me, that's a big number, and we're super active. We have an amazing community, so you are at the right place, and you're gonna have a lot of fun. Basically, just very quick summary of what we do. We basically cover France all over the place, all the major cities, all the major universities, schools, to mention a few of them, like we are in Paris, we are in Lyon, we are in Grenoble. I mean, you can basically see the cities there. Also in the biggest coding schools and also engineering schools. So it's pretty interesting, and you can also see a bunch of the events we have done. There's also some food, so you can always come. It's every month there is something, so you're always welcome to come. This is a very quick wrap-up of the event, of what we do. But basically, just something that you know. I mean, I know it's open to also externals, but I know most of you are from 42. So just so you know, you guys are the largest hub of developers on Starknet worldwide. I mean, again, there's an amazing community of 42 builders. We're gonna have talks from a lot of you guys in the coming minutes. We have two alumni who are going to talk and speak their experience, so get ready for it. But basically, there are over 100 members, alumni of 42 who are today part of the Starknet community. And trust me, it's going to be life-changing for you. I mean, again, this is going to be discussed much more during the talks later, but make sure, I mean, just so you know, you have an amazing community, you are very well surrounded, and you can ask them anything, if you like, on your Starknet journey. And as you may know, we also have done a workshop in the past, a few months ago, that you can see here. Yeah, so this is a very quick list of a few examples of all the 42, and not only, but like the youngsters who have been super involved in Starknet. We have basically some successes stories, a lot of them from 42. And just so you know, those stories have been super amazing, and in a very short period of time. Those kids are basically, they left school like a year and a half ago maximum, and they have made this entire career move within 2 years. So again, it goes super fast, but again, those alumni are going to speak their experience and tell you a little more of their journey. But yeah, basically there are a lot of, you can make a lot of money, you can build company, you can do a lot of things on Starknet. It's an amazing opportunity. So yeah, this is a quick blurb of what you can see. So the start list, the 25 under 25, that's the little joke. Yeah, just real quick, I'm not going to be super long because we have a lot going ahead. But basically you can find all the information here. I can send you all the links later on. You have the Telegram group, you have the events, everything is there. You also have a lot of links, but again, I'm going to send you everything so you can have access to it. And this is also additional programs, additional documentation that you can go to screen, and just to, maybe I can leave you the space for the QR codes, but you can basically have a lot of opportunities to build stuff and to make money from there. Yeah, that's basically it. Just a very quick intro of the upcoming schedule. So it's going to be pretty packed, 4 days, 28th to the 31st, 4 days. So it's going to be the two first are going to be digging the fundamentals and a deep dive, and the day 3 and 4 are going to be actual coding sessions. So, but again, Robert the teacher is going to tell you more about this. But yeah, it's pretty packed. So make sure to follow up and to stay focused on the whole time. Thanks a lot. I'm going to pass the mic to Trinity, who is an alumnus of 42. So Trinity, you can come, and then we're going to have Charles, with also an alumnus, and then Robert to get started on the main meal. Thanks a lot.
Thank you, Luting. Hi, everyone. So we are going to speak about Starknet with one of my mate, Item, our developer experiences in the network. So we discovered Starknet something like 2 years ago. A friend of us introduced us to Starknet. So basically, what is Starknet about? It's there is Ethereum, which is on layer 1, but the main problem on the blockchain is to scale Ethereum, because there is a problem when there is a lot of user, like gas problem. So Starknet solved the problem by adding a rollup on top of Ethereum, and using the Stark technology, like it's allow user and developer to use the blockchain at a cheaper cost and with a good experience. So we are going to speak about our experience in Starknet. Like a majority of you, we are from 42. Like we did 42, like our pool was 2022 August, so it's not that far. And we were at 42 at the common core at the beginning, and so we heard about Starknet, so we decided to jump into this incredible technology. And so, as Luting say, there is some event about Starknet because like they are in Paris, because a lot of developers from Starknet are based in Paris, and especially 42. So we joined Starknet Paris, which is a great community because you can meet a lot of developers, like the Starknet ecosystem developer. You can directly exchange with the developer and start to learn about Starknet. So this is an excellent point to start your journey in Starknet. After that, we directly meet more people during the Ethereum CC in Paris, because like in parallel of this event, there was an event about Starknet. So we met a lot of developer people, people directly involved in Starknet. So we were very confident about this space, and we learned a lot. So don't hesitate to participate to Starknet event, because you will learn a lot from developer, and you will become a developer yourself. After that, we founded Casa Lab, which is like we are something like 7 person, yes. We founded Casa Lab, which is a lab that directly work on the Starknet infrastructure, like Starknet node. We are all from 42. So we learn a lot about Starknet technology, doing some project directly on Starknet. After that, we also did the Hacker House. The last year, it was at San Francisco, and the good thing with Starknet, they are very developer focused. Like, if you are a developer and you want to jump into Starknet, they will do their best to provide you some support. Like, for example, at this event, everything was paid, like our travel to San Francisco. We were in a nice hotel with a lot of people. They like teach us through a bootcamp about Starknet technology and how to deploy our smart contract directly on Starknet, and how to use dApps through Starknet. So it was like very great event. We met a lot of people from the ecosystem, and it was we were really grateful about this event, because it was a really exciting event. After that, personally, so I didn't finish at 42, like maybe like yes, the last project I did it, but directly after I registered on OnlyDust. I can present you OnlyDust. Like, it's a website. You just register through your GitHub, like you link your GitHub to the website, and after you can directly made some contribution, like through pull request to Starknet repository, and every contribution is paid. So you directly get rewarded. And the best thing about OnlyDust is, like, you make money. You don't need any interview like in regular work. You directly make money, and after that, if you did, I don't know, 10 pull requests or things like that, you can directly, like, some people in the ecosystem can contact you directly and tell you, oh yes, I like your work. what about directly working in our startup or something like that? And so you don't have any interview like in the normal system or startup. You can directly work for them, and it's a very great experience because you learn like in 42. You don't have any. You have some docs, some mentor, but you learn directly on the project. So it was really cool. And now there is several programs on Starknet. Luthing told you about the seed program, but there is also another program which is the seed grant, and I am currently working on it with my 42 mate. So like you have worked on Starknet, it's okay. And if you have a good idea, like maybe forking a dApp that you love on Ethereum, but this dApp it's not available on Starknet, you can submit your project. They will review it. If the Starknet community, like Starknet leads, are like, oh yes, we like your idea, I want this on Starknet, you can directly get rewarded with 25,000 USDC, and like you make the dApp on Starknet, because maybe you don't know it, but Starknet don't use the smart contract language like Ethereum, so it's not EVM compatible. Like forking an app, it's not that easy. Like I don't know, between Ethereum and Polygon, you just have to copy paste the smart contract and it's work. In Starknet, you have to rewrite it into Cairo, which is a REST-based language. But if you got the determination and with a good idea, you can do it pretty easily, and you deploy your app, and it works. So my last advice for you guys after the Starknet community, the Hacker House, like the next Hacker House will be in Brussels, and as a student, you can get some free support, like the travel, the facilities are all paid by Starkware. And so during the Hacker House, there is like Hacker House is something like 4 or 5 days. You will learn a lot. You are directly in the community. You can deploy your own project. Like if your project is good, you can go further and make your project a real dApps. So for me, the best advice is to just join Hacker House. So I'm passing the mic to Item.
Hi everybody, I'm just sorry for my fellow English speaker. I just switched to French to be understandable and understood by the non-English speaker, and I'm more. It's more easy for me to speak French. Sorry. Donc pour moi, brièvement, j'ai fait la même piscine que Thomas ici présent. À contrario que lui, c'est qu'on n'a pas eu la même expérience. C'est que moi, je suis pas du tout dans le software engineering. Ça veut dire que j'ai pas fait du Rust, ni même du Kero. J'ai été DevOps. La plupart des choses que j'ai apprises, je les ai apprises par le biais du coup d'OnlyDust et de Starknet. Mon attrait pour le code était pas vraiment là. J'étais à 4.2, donc j'avançais. Là, je m'adresse vraiment particulièrement aux élèves de 42, donc les nouveaux ou ceux qui sont actuellement beaucoup plus loin. J'ai pas fait de... mes attraits pour le C étaient vraiment peu là, et je me voyais mal continuer à faire du software engineering, faire du C, du Rust ou du CPP. Et j'avais besoin d'apprendre le DevOps, mais sachant que c'était assez complexe durant votre cursus de pouvoir possiblement faire autre chose. Donc OnlyDust a été pour moi une ébauche à ça. Donc vous pouvez, par le biais du coup des différents projets qui vous sont mis à disposition, mettre en pratique des choses qu'on voit directement dans le monde de l'entrepreneuriat. Donc je pense à l'infrastructure pure, donc faire de la CI, des CD, apprendre à faire des pull requests et tout ce genre de choses. Malheureusement, c'est des choses qu'on ne voit pas à 42 et que vous verrez peut-être qu'en entreprise. Donc je conseille fortement à quiconque qui souhaite, ne serait-ce que par curiosité, voir ce qui se fait dans le monde de l'entreprise en tant que dev ou dans l'IT, de se tenter à OnlyDust, de faire une pull request pour voir un peu donc du coup toutes les comment dire ça, comment on dit ça déjà, toutes les commodités qu'il y a dans le monde de l'entreprise, genre tu sais, les PR, les CI, les CD, tout ça. Ouais, voilà, genre comment se professionnaliser dans le monde du dev, tout simplement. Donc, si vous n'êtes pas forcément intéressé par ne serait-ce que le C, par le Rust et toutes ces choses-là, je sais qu'il y a de la place vraiment pour tout, pour du DevOps, pour de la cybersécurité, pour de la data, etc. Donc, pour moi, Starknet est vraiment une ébauche à ça, sachant que la plupart des projets sont open source, donc ça vous permet de pouvoir vraiment toucher à un grand panel de projets. Moi, j'avais commencé par du coup des projets qu'on a fait avec Casarlab, ensemble, la boîte qu'on a montée. Donc ça a été le développement d'un produit qui s'appelle le Starknet, qui permet plus ou moins de, on va dire, faire tourner un nœud Starknet sur une petite machine. Donc ça a été un premier pas pour nous dans le monde de l'entrepreneuriat. Puis plus tard, j'ai bossé dans un game engine, et puis j'ai bossé pour Starkware pour des missions de manière très spontanée. Donc je conseille à quiconque de se tenter à ça, même si vous n'avez pas vraiment d'attrait pour le Web3 ou quoi que ce soit. Ça a été mon cas personnellement, je n'y connaissais absolument rien au Web3 et à la crypto et tout ce qui en suit. Et voilà, tentez, allez sur OnlyDust, essayez-vous, allez au hackathon, allez au meet-up, essayez de faire de sociabiliser, de faire du network, et ça peut se faire très vite. Voilà, c'est tout pour moi. Tu as autre chose à dire?
Thank you. Last advice for you guys. There is, because I forget it, but there is also a website which is pretty popular in the Starknet, but also Ethereum ecosystem, which is called Node Guardian, where you can train your skills about Kero or Solidity, and I guess like you get more reward when you got a good Kero Node Guardian profile on OnlyDust. So it can be a good way to train your smart contract skills, because like we are few developers in Rust, but in Kero it's more difficult to find some good developers. So if you want to do some smart contracts, Solidity is good, but Kero can be a really great language, because it's like Turing complete. Like you can write some smart contract, but you can also reuse it to make some verifiable programs. So yes, it's all about Node Guardian, and it's okay. Okay, thank you very much. Thank you guys. Thank you Luting and Wilfried. And I guess I will pick the mic to Charles. You guys have any question? It's okay? Okay, after. Thank you. Charles.
On peut revenir en arrière ou pas? Ah ouais, ça. Carré. Can I go back on the slides? I mean, I will probably, yeah, okay, cool. And do I have to aim something? Uh-oh. Now you hear me? Do I have to aim something to pass the slides? Yeah, but it's not. It seems like it's not working. Yeah. No, it doesn't work. Ah, it's working now. Okay. So thanks everyone for coming here. I will be presenting Starknet, the core concept, and the blockchain, because maybe some of you here are not very familiar with the blockchain. Like who here is familiar with the blockchain? Okay, so definitely not everyone. So after that, it will be the first part. After that, I will talk about my journey in the Starknet ecosystem, because now I'm working at Starkware as an employee. Starkware is the company that built the Starknet. And yeah, so to start about the blockchain, let's imagine that you're Turkey. That's you. And I have some good news for you, because the life of a turkey is quite cool, actually. This is 1,000 days in the life of a turkey, and every day it's even better than the previous day. So yeah, I'm very happy for you. But I also have a bad news. Yeah, this is what happened on the next day. this is Thanksgiving, and you're dead. That's too bad. So I think we can learn something from this short lesson. That is like, we should not trust Americans. That's what happened to you when you trust American people. And we can try to generalize this concept to maybe us, humans, and not turkeys. So this is Alice. She loves turkeys. And this is Bob. He's the guy who killed you in the previous slide. So that's a turkey seller. And this is a bank. So Alice wants to buy a turkey to Bob. So she will say, give $100. I get that the price of a turkey, maybe not, to Bob, the turkey seller. And the bank will say, yeah, okay. And then Bob will say, here is your turkey. So that's cool. But what can also happen is that we are trusting the bank here, like the turkey trusted Americans before. So the bank can say, no, I don't want because Bob is Russian, and I don't want to give money to somebody who is Russian. Maybe the bank is against selling turkeys, so the bank will refuse also. And that's what happens when you want to buy crypto with a common bank, like not N26 or Revolut, but something like a more regular bank. The bank can say, no, I don't want you to spend your money on crypto. Like, that's your money, but you're not allowed to spend it on whatever you want. That's a shame. And the bank can also say, I'm sorry, I lost your money because I gambled it on, I don't know. And that's what happened like with Lehman Brothers in 2008. And that's a shame also. So a solution will be to remove the bank and to have a system where you can just like we don't have to trust anyone. And that's how blockchains work. Like this is a bunch of computers connected together. We'll call these computers nodes. And Alice will just ask to one of the nodes to send $100 to Bob, the turkey seller. And the computer will like propagate this transaction to other nodes on the network, and then they will process to a vote. So the vote is occurring, and then at the end of the vote, they decide if yes or not the transaction is valid. And if it's valid, then the money is transferred, and if it's not, like, no, it's not valid, and the transaction is not is cancelled. For a transaction to be valid, you just need to have Alice to hold enough funds. Like if she has $100 at least, it's fine. And if we have a proof that it's Alice who decided to send this money, like it's not someone who wants to steal her money, and we like someone who could say, Alice wants to send money to Bob. Trust me, I'm Alice, but it's actually not Alice. So, no, sorry. So that's a good idea, but there is only 6 computers here, and I had to draw a lot of arrows, and it was really complicated for me to draw it. Now imagine with like 1 million computers, that's terrible, and that's not scalable. Like you can process a few million transactions per day maximum, but not billions of transactions, like with this poor system. So if you want to buy a turkey with this system, you will have to like wait for hours. If you like everyone on the planet who are using this, you will have to wait for hours for your transaction to be processed, and you will be like waiting for your turkey for way too long. A solution will be to just remove some computers and just say like, if you want to participate and to vote, you don't need to have a computer, but like to have a supercomputer. So it will be fast, and we are sure that the voting system will be very scalable, and that's what Solana does. Solana is a pretty famous blockchain, but by doing that, you remove a lot of computers, a lot of nodes, and it's easy to corrupt the vote, like to tell to computers, if Alice wants to send money to Bob, just refuse the transaction, even if it's a good transaction. So we have to trust, again, that nobody will try to corrupt these computers. This is what Solana does, and actually it works, but there is a risk of centralization. So we need to find a better solution, and that's what Starknet tried to do. So the idea with Starknet is to, like with Starknet, we have a language which is called Cairo, and in Cairo, when you write a program, you can run it, and you will have an output, like in C or Python, but you will also have a proof of this output. Like, let's say I run a program, it takes 1 hour to give me a number, I don't know, 42, and I want to verify that it's really 42 the answer, so I will have to run it again. because I have no proof that it's 42. And I want to prove, like, I don't know, someone that it's 42 when you run this program, the output. I have to run it again and to wait 1 hour. It's a shame. With Cairo, you write your program, you run it one time, it gives you the output and a proof of this output. And you can verify this proof, and the verification of the proof is very fast, like a few seconds or minutes, I don't know, depending on the complexity of the transaction. And this way, we can have a system like that. Like Alice will tell Starknet, which is this weird computer with the gear, gives $100 to Bob, the turkey seller. Starknet will generate a proof that the transaction is valid. Like there is a program which will run the transaction. The output will be yes, it's valid, or no, it's not valid. And if it's valid, the transaction will go to the blockchain here, and the vote will occur. But it will be faster because the verification of the transaction is easier if we just verify the proof of the transaction, like I've explained before. And that's cool. We can scale the blockchain this way, but not enough because we have to go from millions of transactions per day to billions of transactions per day. And that's cool, but that's definitely not enough. But what we can do is this. So actually, we have like 1,000 Alice saying to Starknet, I want to give a lot of money to Bob. Like they all want turkeys at the same time. Bob don't know what is happening. And Starknet will just generate one big proof for all these transactions. So you will have only one vote for one proof, but inside this proof there is 1,000 transactions. And this way we can go from millions of transactions per day to billions of transactions per day. And something which is cool is that the complexity of the big proof which aggregates transactions is evolving logarithmically. I don't know if you can say that, depending on the number of transactions there is in the proof. Meaning that if you want to prove 900 transactions, or maybe 1,000, it will be almost the same, because at some point it becomes just flat. And that's a way to add even more transactions without having the network to go slower. So it won't be congestion. So we did it. We scaled the blockchain, and now we have a solution which is usable for everyone on the planet, and we don't have to trust banks anymore, and we are safe. We can, yeah. I will just skip this. We will do that at the end of the talk. So the second part, now that you know what is blockchain, why do we need blockchain? The payment stuff for blockchain is just an example, but we can do much more with blockchains, like just to vote for politicians, or like to exchange. I mean, we can do a lot of stuff with blockchain. It's like the internet. We can have websites, but we can also do, I don't know, messaging application. So that's just an example, so you can understand what blockchain can unlock, like features. So this part will be about my journey and how I ended up here. So I started like you at 42. And I've reached the level 19, not 21, 19, it was 6 years ago, in 2018. After that, I've decided just to stop and not to go to 21 because, I mean, I was ready to work. So I decided to become an iOS developer. It was cool. I've tried to do it in freelance. It was a failure. So I just took a full-time job, and it was interesting at first, but then I just feel like it was useless. I was just like linking buttons to API and doing it over and over and over on different projects. I was not very happy with my life at this point. So I decided to go back to blockchain. Like I've discovered Bitcoin when I was in high school, and it was really interesting. I've continued to develop stuff on it, on Ethereum, like a hobby always, on my personal, like for personal projects on my free time. And then I decided to switch from iOS to try to dive a bit more into blockchain and to see if I can maybe have a job in this field. And after a few months of doing that, I've decided to start my company with a friend. You may know him, it's Le Règlement on YouTube. I know, okay, a few people. That's cool. So we started the company together, and the company were not making money, so we stopped the company after 2 years. But it was cool. We did that on Starknet because we wanted to have something on the blockchain with decentralization, not like Solana, but with fast transactions and low gas costs, like low transaction fees. So that's why we decided to go on Starknet. And at that time, it was in late 2021 that we started this company. Starknet was really early, really young, so we had to build a lot of tooling, a lot of infrastructure, and yeah, it was really difficult at the beginning. After stopping the company, I've decided to take a break and just to do some freelance on OnlyDust, like Trinity told you before. So that part might interest you because you don't want to stop your cursus at 42 maybe, and you still want to make some money and to start like working on open source project but getting paid. So you can do it like I did. I was just free to do whatever I want, and just sometimes I go on GitHub, I scroll through issues, I take one I like, I solve the issue, and I get paid, and that's it. And that's pretty cool. And after that, I've received a lot of propositions from companies I was working on. So I decided to go back to a project and not to just work on some issues, but to get involved into something. So I decided to accept a job proposition at Starkware, and that's what I'm doing now. It's been a few months, and it's pretty cool. I mean, it's fully remote. I can work in every time zone I want, and my coworkers are cool. And I'm working on some interesting projects. So yeah, and also I'm talking about the tech only since the beginning of the talk, but if you like money, actually the difference between, yeah, you like money? Actually, the difference between my last salary as an iOS developer and now is this, which is pretty cool. And it's not to flex or anything, just like there is money in the space. If you don't like the tech, but you like money also, you can come. Yeah, I think that's it. Here's my Twitter if you want to drop a follow. So we'll just skip all the questions. I don't know if there are anything. Okay, yeah, you have a question? Yeah, it was because I was working on Starknet since a long time, and then after working on OnlyDust, before I was working on my own project, so I was making some contributions, but it was not most of the time. And during my freelancer era, I had the opportunity to contribute even more to the ecosystem, and then to get even more reputation, and then I received these offers. It wasn't just like, come work for me, and I said yes, I had to pass some tests and everything. But yeah, that's the kind of offer you can only get if you work already in the field on OnlyDust. Do we do the question at the end, or? Yeah, at the end. Okay. Yeah.
Est-ce qu'on peut avoir une explication en français de la raison pour laquelle il n'y a pas de congestion avec Starknet, contrairement à Solana?
Okay, so I may just switch in French for this question. Pourquoi est-ce qu'il n'y a pas de... En fait, il y a de... Ça scale comme Solana, la blockchain, c'est-à-dire que, si je reviens sur cette slide, Solana, la solution qui est mise en place, c'est juste de supprimer des ordinateurs qui sont lents, et donc on a que des ordinateurs qui sont hyper rapides sur le réseau, mais on a genre 3000 nœuds, je crois, je sais plus exactement combien ils en ont. Mais bref, il y a moins d'ordinateurs, donc le vote va plus vite, et les ordinateurs sont aussi extrêmement rapides, donc ils peuvent se permettre d'avoir des requirements au niveau du nombre de transactions qui passent par seconde, qui est beaucoup plus élevé que sur un réseau classique où même un téléphone peut se connecter. La différence avec Starknet, c'est que plutôt que de réduire, d'augmenter les requirements nécessaires pour se connecter au réseau, on décide juste de rendre les transactions plus rapides à exécuter. Donc, plutôt que d'avoir des grosses transactions qui passent sur des grosses machines, on a juste des petites preuves qui passent sur des petites machines. Donc, on peut avoir toujours plein d'ordinateurs sur le réseau, donc avoir un truc bien décentralisé, mais en même temps exploiter seulement une petite partie de la puissance de calcul de ces machines-là, et toujours avoir beaucoup de transactions qui passent, comme c'est le cas ici. Là, il y a juste une seule preuve qui va être votée. En fait, dans cette preuve, il y a 1000 transactions. C'est comme ça que ça fonctionne, en gros. Okay, so we just... yeah, I mean, if there is question, but I think we'll do it at the end of the introduction. Yes, Christian?
Did you finish? It's
Yeah,
over.
it's done.
Your part is finished?
Yeah, I will just
Okay,
put that.
so let's do the questions now. Yeah?
It's, okay, we can continue the questions?
Yeah.
Okay, so you had a question?
On peut repartir sur le schéma qui était avant?
Yes. Ça?
Ouais. Donc c'était pour comprendre. En fait, qu'est-ce qui se passe? On doit attendre que, enfin, enfin, comment dire, si on attend qu'il doit y avoir plusieurs demandes de transactions pour aller la valider, c'est-à-dire qu'il n'y a pas un temps d'attente qui est trop long au final?
Actuellement, c'est 1 à 2 minutes. Enfin, non, avant que...
Avant que ça passe voilà, sur le...
Ouais, pour l'instant, c'est quelques heures. Mais en
Ok.
fait, une fois que ça a été validé déjà sur Starknet, bah, on est sûr que ça va arriver sur la blockchain. Mais effectivement, si on veut vraiment être sûr à 100% que ça soit validé sur la blockchain, donc on appelle la L1, c'est quelques heures actuellement. Et le end goal, c'est qu'au bout d'un moment, ça soit instantané, quoi. Tu envoies ta transaction et que bam, ça soit validé. Mais ça prendra quelques années, le temps de développer la tech.
Ok.
Okay, any other questions? Okay, cool. Thank you, everyone.
Une dernière question.
Ah, une question encore? Yes. Next slide.
Yeah, sorry. I just had like one question. Why did you build a new language instead of using Solidity? Is it for the tech or?
Do you want me to explain that? Or? Okay. Yeah, so there is two possibilities. We can either continue with Solidity and to have an EVM compatible chain. So just to explain, this blockchain is Ethereum. We can use different blockchain. We decided to go on Ethereum because that's the best one actually. About decentralization, and a solution will be to continue to use Solidity and to generate proof with Solidity, like zk-sync DAOs or Polygon or a lot of other similar technologies and concurrents. We decided to go with Cairo because we can get rid of the EVM. So it's like reinventing the wheel, but EVM is a terrible wheel. So that's a good thing to do. We have a way better language, and yeah, we can do much more things with the Cairo compared to Solidity.
Alors, en français, je vais peut-être aussi faire parce que c'est une question qu'on nous pose souvent, celle-ci. Très rapidement. Je me permets, je vais te faire une réponse un peu plus simple, un peu plus basique, mais j'espère que ce sera un peu plus clair. Enfin, plus clair, je veux dire, l'idée, hein, dans l'idée. En fait, de façon très simple, pourquoi est-ce qu'on n'utilise pas Solidity sur Starknet? Parce qu'en fait, sur Starknet, on utilise des zero knowledge proof. Alors en l'occurrence, c'est pas techniquement des zero knowledge proof, c'est ce qu'on appelle des validity proof, parce que bon, pour plein de raisons. Et finalement, cette techno, elle permet deux choses. Elle permet de la privacy, elle permet aussi de scaler, d'avoir beaucoup plus de transactions, de throughput sur une blockchain. Donc de capacité de volume de transactions à faire à la seconde. En l'occurrence, pour des raisons que je vais éviter, on n'est pas vraiment aujourd'hui un zk rollup, on est uniquement un validity rollup, donc on utilise uniquement la partie scalabilité. Et pourquoi est-ce qu'on utilise un langage de programmation spécial? C'est qu'en fait, pour leverager cette techno-là, en fait, Solidity, ce n'est pas un langage qui est fait pour ça. Comme il l'a expliqué, ce n'est pas un langage qui permet de créer des fraud proofs. Et en fait, l'analogie que j'aime bien donner, c'est que si tu veux parler avec quelqu'un qui ne parle pas ta langue, tu as deux options. Soit tu utilises un traducteur, un Google Translate, et aujourd'hui, on a des traducteurs qui sont extrêmement efficaces. C'est super, c'est génial. La seule chose, c'est que tu seras toujours limité dans la finesse de ce que tu pourras communiquer avec la personne avec qui tu parles. Tu ne pourras jamais lire un livre compliqué, tu ne pourras jamais lire un livre de philo en utilisant un Google Translate. L'autre option que tu peux faire, alors cette option-là, elle est très pratique. Je veux dire, tu n'as pas besoin de quoi que ce soit, juste tu traduis et c'est fini. L'autre option, c'est d'apprendre la langue native de la personne à qui tu parles. Alors c'est beaucoup plus compliqué, c'est beaucoup plus lourd, c'est beaucoup plus contraignant, mais à la fin de la journée, tu pourras être beaucoup plus fin dans la finesse de communication. Donc en fait, l'idée d'avoir un langage spécifique, c'est d'avoir un langage qui te permet de leverager complètement, sur mesure, les features, les caractéristiques des zero knowledge proof, en l'occurrence là des validity proof. Finalement, c'est avoir un langage sur mesure pour pouvoir faire exactement ce que tu veux dans ce périmètre-là. Alors que Solidity, ce serait un peu du bricolage finalement. Est-ce que c'est clair?
Okay. Hi everyone. How are you guys doing? Holding up? Cool. So for the next part, I'm gonna do a Basecamp. It's a special Basecamp for a special Basecamp French edition. Fortunately, I don't speak French, so I'm sorry for that. If you want to get access to the presentation, you can scan the QR code. Otherwise, I guess it's going to be sent in the chat or somewhere. You have all the information about the Basecamp in this document, but it's also going to be available on YouTube. And yeah, let's get started. So about this Basecamp, it's basically a Starknet Foundation initiative. We've been running these Basecamps quite a few, I think, for at least 2 years now. And we have a collaboration with 42 Blockchain that we're doing this Basecamp. The aim of this Basecamp is to onboard developers to Starknet and teach you about Cairo and Starknet and how to start your journey as a developer and earn various grants or money or whatever you want to build. It's going to be a 4-day course taught live. Fun thing about it is my first time doing it live. Before this, I was doing it in front of a computer, so it was a bit more simpler, but now we're doing it live, so I'm excited about this. Each session consists of 2 hours, so basically, I guess we're gonna go over time a little bit, so hopefully that's okay with you guys. We're gonna take a break somewhere, but we'll do a temperature check to see how you guys holding up. And finally, if you have questions about things like Cairo, Starknet, or different programs, make sure to check the Discord channel named Basecamp, and we'll be there to help you. Good. Now, the sessions that we're doing. So the first session, which is going to be today, it's going to be all about fundamentals. Then tomorrow we're going to do a deep dive into Starknet. And finally, the last 2 sessions are going to be practical sessions. So if you bring your laptop, that's going to be cool. You can code along with us during the Cairo session. We're going to do some Stark links. And finally, we're going to do smart contracts, the session 4. As for teachers, my name is Robert, and I'll be doing the first 3 sessions. And the last session is going to be done by Charles. I'm from Starknet Foundation, and Charles already introduced himself. He's from Starkware. Okay, so let's start with the journey to set the path for the developer journey. We'll start first with the Basecamp. We'll prepare you in terms of Cairo, how to learn to code with Cairo programming language, and about Starknet. Then, after the Basecamp, we're going to have a bootcamp, which basically aims you to train you further, take up these skills, and practice them. You'll be able to join a team, or even create a team if you want to, and then you can work on certain project and practice your skills. And in this bootcamp, we'll assign mentors for you to get help, or if you have any questions, the mentor will be able to help you. And you can register there. I think the registration so the bootcamp will start on the 10th of June, I believe, but I'll get to that in just a second. And finally, we have StarkHack. StarkHack is a hackathon, which is sponsored by Starkware, and it's done by ETH Global. And you can compete to this hackathon and win up to 75K or 75,000 in prizes. And it's a remote hackathon, so everybody can join. You can create a team, you can form a team, and then work on an interesting idea. And all of this, the first 2 steps are preparations for you for the hackathon if you want to. And for becoming a developer on OnlyDust, and then you can work on different projects as well. Now, regarding bootcamp, it's first of its kind. So it's cohort number 1. It's going to start on June 10th. It's organized by one of our colleagues, Gian. It's a 4 weeks, and you'll be working on one project. It's going to work in teams, so you're going to form a team, as I mentioned, but you can join as a solo developer as well. And you're going to be paired with mentors for regular calls. And finally, you're going to get continued support for your application. So if you have an interesting application or proof of concept, there's certain grants from the foundation, such as the Builder grant, that's going to be good for you to continue the development on that certain application. The agenda is basically in week 1, you're going to do the ideation and team formation. Then on week 2 and 4, you're going to work on the application itself. And finally, week 4, it's for submissions and demo. Cool. Any questions so far? Feel free to just jump in, because it's kind of like an open session. I'm not going to leave every question at the end, because it's going to be a lot of questions. So, okay, no questions? Good to go? Okay, now let's start. So, Starknet fundamentals. The session 1. About this session, we're going to learn the topics we're going to start with why Cairo. So Cairo is a provable programming language that we already learned some things about it, but I'm not going to go in more detail and explain what it is. Then we're going to see why Starknet, why build on Starknet, what does Starknet has to offer. Then we're going to talk about smart wallets. So if you heard about the term account abstraction, smart wallets is account abstraction. I said 10 minutes break, but we'll play it by the ear how this goes. So if you feel good to go, and we can do without break, or if we want, we can take a break. And finally, we're going to talk about the architecture 101. Now, you may heard about Starkware, StarkX, Starknet, Starknet Foundation. It might present itself as a confusion between all of this, so let me try to clarify this with this slide. So initially, Starkware, it's the company that has developed all the technology, all the underlying technology that currently Starknet has. Starkware is the company that Charles is working for, and the CEO of Starkware is Eli Ben Sasson. He's also the mathematician and inventor of the Stark's proof system. StarkX is a service that has been created by Starkware, and it's the first iteration of implementation of the ZK proofs. It's basically a permissioned layer 2 Validium. So basically, if you want to use it, you would have to have some sort of collaboration or a contract with StarkX to be able to use this. You can think of it as a scaling engine that powers projects such as Immutable X, Sorare, DYDX, RhinoFi, and so on. And fun thing about StarkX is that Cairo was actually created, the first version of Cairo was actually created specifically for StarkX to be rewritten in Cairo. As the development continued to develop, or like the more developments in the technology, there was soon the question, we should share all of this technology with the public. And this is where Starknet emerged or was created. Starknet is basically a layer 2 rollup, a permissionless layer 2 rollup, which everybody can access. They don't have to sign a contract. They can just go on Starknet, learn Cairo, and develop their own smart contracts and deploy them. So Starknet, it's built on top of Ethereum, and it's a layer 2 rollup. And finally, the Starknet Foundation, it's the non-profit organization where I currently work. And the aim of the foundation is basically to create onboarding sessions such as these ones, or help with grants for developers or projects to enable them to deploy and develop their projects, and with governance as well. All clear by now? Okay, so Starkware is the company, StarkX is a service, is a scaling engine that powers projects like DYDX, Immutable X. Starknet is the layer 2, which is the permissionless layer 2 rollup. And the foundation, it's a non-profit organization. Cool. Now the question is, why Cairo? Why did we decide to build our own programming language and not use Ethereum, for example? I'm going to try to explain this by giving you an example. So imagine all of you are the head of the space exploration in your country, right? And your mission is to basically, you have to go with the spacecraft on a certain planet. And then you have a few questions here, like how can I save the most fuel out of it? How can I scale or make my spaceship smaller? And for this, we'll have two questions that we try to answer. So the first question is, what's the best launch window? And then the second question is, what's the best trajectory? Obviously, making this by hand is going to take a lot of time. So what you have is that you have a set of engineers, and you requested them to create you an application or a program, an algorithm, that finds these specific answers for you. So going back, and then this algorithm is going to be written in a programming language such as Rust, which is a high proficient programming language. So your engineers are coming back after several weeks or months, depending on how hard you push them, and they're coming back with the program. Now, the issue with this program is that it's going to take a lot to run. It's a lot of computation power, and you do not have the resources. So basically what you need to do is you have to execute it in a supercomputer, right? And your company or your country doesn't have access to a supercomputer. So what we do now? We have a rival country that basically offered us, hey, I can help you run the program, and I can send you back the result to you. So given the fact that you're kind of like out of option, you decide to try it out. You decide to give it a go, right? So what happens is that you're sending your program to the rival country's supercomputer. They're going to execute it for you, and they're going to send back the result. Now, with this situation, it kind of like opens a can of worms or opens the door to a few issues. How do you know you can trust the result? Maybe the supercomputer malfunctioned at one point, a bit flipped, and the whole output is totally different, so you cannot trust the result. Or even a rival spy agency sabotaged the result, so you really cannot testify that indeed this result is accurate. What you can do is basically talk to other countries that have supercomputers and make them run the program again, and then you can compare the results together to see if the result is the correct one. This is basically what Ethereum does, right? So there's a bunch of validators that we are re-executing the whole process again, and then they confirm that the final result is indeed the final result. Now, let's go back. Let's go back and talk to the set of engineers and tell them, hey, write the program in Cairo, a provable program. They're going to write the program in Cairo. They're going to send the same program to the supercomputer. And now the rival country is going to send you the result back together with a proof that has been generated from its execution. What you can do with this proof is you can actually verify the proof for its validity. You can verify if this proof is correct. And if this proof is correct, you can have certainty that nothing has malfunctioned in the execution of the program. And if something intentionally happened, the proof will be invalid. So if the supercomputer or the rival country tries to forge a proof, it will be invalid. So what you can do is you can verify this on your end, and the nice things about it is that you can even verify it on a regular laptop, right? So proof verification doesn't require a lot of computation. So in this sense, you can even keep a supercomputer honest with just your regular device. So this is a very powerful thing. And these are like Cairo's features. So just to recap, Cairo creates provable program. It runs on top of the Cairo VM, which means that we are not EVM compatible, and we decided to create our own programming language, our own stack and everything, just because we want to be heavily optimized for these ZK circuits to make it performant. The syntax, if anyone you are familiar with Rust, maybe a raise of hands. Okay, so for you, Cairo is going to will look alike. It doesn't have one-to-one resemblance, but its syntax is almost the same. It has a similar ownership model. It has strongly typed, has traits, macros, and the nice thing about it is that it can be used outside of Starknet. So what it means that I can just create my Cairo program independently. I can generate my proof, and I can use it anywhere else. Like, you don't have to stick to Starknet. With that proof, you can go on other chains and do interesting things. And finally, I think this is the best thing, the last line. You don't need to know ZK, so you don't need to know about zero knowledge. Everything is abstracted in the Cairo program. What you need to focus is developing your application, and there's no need to know ZK. But if you're interested, obviously you can do it. It's my mom. Yeah, cool. So let's get a sneak peek into what the code looks like. This is vanilla Cairo. So we have a struct, which is basically a custom data type, and this struct is called rectangle. And inside this struct, we have different type of variables. In this case, we have scalar types. So we have height, and we define the data type. So it's an unsigned integer 64. There are multiple unsigned integers, so ranging from U8 until U256. And we have a width as well. So this is just how you define a custom data type with the struct. Next, it's a trait. So traits are basically a functionality blueprint where you define the method signatures. So in this trait, we name it shape geometry. And then we have two functions here, boundary and area. Note that here we just define the inputs and the outputs and nothing more, so only the method signatures. And you can think of it as a blueprint, right? And finally, we have the implementation of that trait that we created. So in this implementation block, what we're doing is we basically define the code logic of that trait. So this is where all the logic comes in place. So I think compared to Rust, implementation block don't have a name. So in this case, we name it rectangle geometry. And yeah, inside here we have boundary, and then here we define what's happening actually in the function. So we calculate the boundary and we calculate the area. Okay. Now let's go to the smart contracts side. So this is just a sneak peek. During session 3 and 4, you're gonna get a deep dive into them. You're gonna get your hands dirty and just code along, so that's gonna be exciting. Now, regarding smart contracts, what we have here is a simple module that it's called simple storage. And modules are basically a group, a subset of groups of functionalities inside this module. So to let Cairo know that we're building a smart contract, we have to mark it, or yeah, we have to tag it as a Starknet contract attribute, which basically in today's programming world is called metaprogramming. And this attribute or macro, what will happen is that it's going to consume the module code, and it's going to transform it specifically to a smart contract. So that's how we tell Cairo that, hey, we're building a smart contract. It's not vanilla Cairo. Inside the smart contract, what you need to have is a storage. So every smart contract has its own storage. And this is defined by struct storage. Storage is a reserved name, so you have to use it. You cannot name it something else. And inside the storage, we have the stored data of unsigned 128. So this is the thing that we're storing on the block explorer. And you have to use the attributes storage to mark it as a storage. That's how we tell Cairo that we're working with the storage. Next up, it's again the trait example that we've seen in the Cairo, vanilla Cairo. This is how we define a simple interface or the public function of your smart contract. So basically the public function that other blockchains or contracts can interact. And here we have trait iSimple storage, and T contract state is basically a placeholder, a generic placeholder. You can name it whatever you want to, so either T or T contract state. And inside here we have the method signatures. So we have set and get. Now the difference there's a small, I mean, it's a big difference between these two. Can you guys know what's the difference between the two? No? Yeah? Yeah. So basically, set allows you to modify the contract state because we're passing a reference to the contract state. You can see ref self, and then we have the placeholder, and then we have a variable x. And then the function get, it's only a read-only method or function. And how we do this is that we have this symbol at, which is basically a snapshot. And this snapshot, what it does, it sends a copy of the contract state at that certain time. So you're not able to modify a copy because it's not the actual contract state, it's just a copy. So set, you'll be able to modify the state of the contract, and then get, you just read it. You cannot modify it. And finally, we have the implementation of that interface. And here we define the code logic for set and get. The implementation has to be marked with an ABI embed v0 because these are public methods or functions that are accessible on the block explorer. And embed v0, so the v0 is basically more about future compilers to be compatible with future compilers. And then inside here we have, for the set, we have the ref self contract state, and then we're able to call self, access the storage variable, which is stored data, and then we can call the function write, which allows me to update the value of stored data. And then similarly for the get, we are just reading the value and returning it. Okay? Any questions? I'm sure you're gonna have during session 3 and 4 a lot of them, so yeah. This is just a sneak peek, nothing scary. Okay, so now let's do a summary about why Cairo. So Cairo basically is a general purpose programming language that allows you to create provable programs. It allows you to do proof of computation integrity, so you can verify the computation integrity. Verification without re-execution, so you don't have to re-execute the whole program again, you can just use that proof to verify it. It's a powerful and flexible language, so it's because it's inspired by Rust and it's fairly a new language, it's quite powerful and flexible and new things are being added all the time. It prevents cheating and malfunction, and as we've seen with the example with the space exploration, you can even keep a supercomputer honest, so with your regular laptop or device. Okay? Now, next question. Why Starknet? Why we decided to create Starknet? So, let's go back a little bit and explain what's happening on layer 1, like the layer 1 scaling issue or the scaling problem. Imagine, I mean, there are thousands or 10,000 of machines that are running Ethereum, and from time to time, a randomly machine is being selected to produce a new block, right? And when you produce a new block, what happens is that you have to execute a bunch of transactions, and after that, you're gonna propose a new global state, and for simplification, let's say that this new global state is 42. Now, what happens is that validators, they do not believe you that the new global state is 42. So they're gonna re-execute everything from the beginning, and they're gonna re-execute all the transactions, and they're gonna verify if this result is actually the one that you proposed, right? So you can see, again, the cool animation. So they're gonna re-verify everything, and if the new global state is valid, it's being passed on. This is quite a robust method, and it's part of the consensus algorithm. If more than, the only idea is that more than 50% has to be, 51% has to be valid or true or honest. But this presents a bit of an issue regarding scaling and performance. So how do we solve this? Now, let's see on Starknet how this works. So on Starknet, we're doing the same thing. We're producing a new block. So the sequencer produces a new block, and it proposes the new state being 42. Addition to Ethereum, being written in Cairo, which we learned a few slides ago, it also generates a proof, which you'll see that small dots, it's basically after the small dots are the proof generation. So it takes a little bit of computation. Now, what happens is that you send this proof to the layer 1 on Ethereum, and then the validators are picking the proof up, right? And they're gonna validate the proof. So what happens when you validate the proof? It's gonna be just a fraction of the execution. So they don't have to re-execute all the transaction again and again. They just have to verify that certain proof. And if the proof is valid, you have certainty that the new global state is 42. So that's what's happening on Starknet. Now, obviously there's a bit of trade-off because we have to generate the proof, which technically there's more computation involved, but the idea is that once it's being executed only once and then verified everywhere. So hence the title, execute once and then verify everywhere. Now, let's see how cheap is this proof actually, how cheap we can get. So imagine the X is basically the number of steps in the block. We have the executed transactions on the sequencer, and then the validators are in polylogarithmic time. So we have log square of X. And let's see how this compares to. So we have here on the chart, we can see that with more transactions in the block, the cheaper it gets and the bigger the gap between these two are. So the execution goes exponentially almost, but we have polylogarithmic time on the verification. Now, the nice thing about this is this is going to improve, the gap is going to improve and become bigger with proof recursion, which we're going to study in the next session. So, just to illustrate what Stark technology is. So imagine like what validity proof is for computation. You can think of what the zip algorithm is for file size. So the zip algorithm is basically a compression to reduce your file size. And the validity proof is basically a compression of computation. That's kind of like the analogy I would like to go with. So, back to our validity proofs, or ZK proofs. So, validity proofs basically have a use case for zero-knowledge proofs. Those two use cases is privacy and scaling. We are focused more on the scaling side and not on privacy. What it does is basically convinces the verifier on layer 1 that of a new layer 2 state without sharing the transaction details. So it just sends the validity proof, not the whole execution. But this doesn't make it private. So still, all your transactions on Starknet are public. So we're not focused on privacy, we're focused on performance and scaling. It makes verification efficient. And we like to refer to validity proofs as validity rollups and not ZK rollups. I believe ZK rollups is meant more for privacy. And for us, we refer to them as validity proofs. The ZK rollups or ZK proofs are more the marketing term that goes around the industry. It's based on Starks and not on Snarks, and it's efficient in proving and verification. And we'll do a comparison between these two in just a bit. Now, Starks versus Snarks. There are two items here. So first we'll look at the verification between these two. And we'll notice that Stark is polylogarithmic time, while Snark is constant, right? So it doesn't matter of its complexity, it will always be constant. The proof size on Starks, it's roughly around 400 kilobytes, while on Snarks, it's almost 300 bytes. So from these 2 points, you'll say, why are we sticking with Starks? Why not switch to Snarks? Now, the next 3 points are extremely important, and these are the benefits that allow us to scale the entire system. Proving time. It's much, much faster compared to Starks. Then, trusted setup. We don't require a trusted setup on Starknet. While on Starks, you need to form a trusted setup before you start everything. So basically, you need some private variables or values in your setup, and if these private values are not handled correctly, and maybe even leaked, all your setup is destroyed, and its security at stake. And finally, Stark proof are deemed to be quantum secure. So if tomorrow ChatGPT becomes aware, or a quantum computer becomes powerful enough to break elliptic curves, all other cryptographic primitives are not safe anymore. So with Starks, it's quantum secure. Make sense? Cool. Now, why did we decide to build the whole VM for us and not be compatible with the EVM? Especially Cairo VM, that's what our VM is called. So the difference between ZK rollups is that if you try to be EVM compatible, there's certain trade-offs. So the trade-offs is basically being compatible and being performant. And those who are ZK EVMs are compatible with Ethereum, but they're going to have some issues on the performance side, especially in the future when they try to scale. With Cairo VM, we decided that we're going to risk compatibility. So we don't want to be, it's not that we don't want to be compatible, but we aim and we put the point on performance, because building a ZK circuits, you need a whole stack of new technology. The EVM is not meant for ZK circuits. So that's where we decided to have to build a new programming language. We had to build a new stack, and we have to develop all the technologies and libraries like toolkits and everything. So, but we are thinking long term. We're thinking in terms of performance. We want to make this scalable, and we want to think in the future and make this the most performant of all. So there's the certainty that there's a trade-off between these two, and let's see how this compares to the classification made from Vitalik. So maybe some of you remember a post from Vitalik. He talked about the ZK EVM classifications. And for the first type, it's basically fully compatible EVM. There's no changes at all. It's like Ethereum. But the performance for ZK proofs is extremely slow. And currently, there's no projects doing this. Type 2, compatibility is quite high. There are small changes to the EVM, such as the storage data structure. And the performance still is not that good, so it's still slow. And we have to yet see a project working on Type 2. Now, interesting things come with Type 3. The compatibility is partial, and there are some changes to the EVM. So we have the storage, hashes, and precompiles. Performance starts to get better, so it's fast compared to the other types. And we start to see that there are new projects are already working on this. So we have ZK Sync, we have Scroll, and we have Polygon ZK EVM. And we have Kakarot. So anyone heard about Kakarot? Nice, nice. So Kakarot is basically built using the Stark's technology, the Stark technology. And it's basically a transpiler, a bytecode transpiler from Solidity to Cairo. And it's also built in Cairo. If you want to find out more, you can type Kakarot ZKVM on Google, or maybe, I don't know if that's a link, but yeah, you can search it. And finally, type 4. It's completely different VM, doesn't resemble at all. You have no compatibility whatsoever, but you get a very performant ZK. So as projects, what we have here is Starknet, which is non-ZK EVM compatible, or non-ZK EVM. We have our own VM, it's called Cairo VM, that we showed previously. And then there's another project called Polygon Maidan that's also working on this. And finally, there's an asterisk on Aztec. There's a little bit of difference. They are focused more on the privacy part, and there's a little bit more difference, but they're doing the same thing. They're not compatible with the EVM, and we're all focused on being performant and basically develop this new type of paradigm, the ZK proofs or the ZK circuits. Again, EVM is not meant for ZK proofs. It's just very difficult to work with them. Okay. Now, regarding finality, so the term finality is basically when the transaction has been settled. You cannot change it, or you cannot modify it, or you cannot revert it. On Ethereum, it takes roughly about 6 minutes to reach finality. And then optimistic rollups, you have roughly 1 week. So basically, if you want to withdraw from layer 2 to Ethereum, it's going to take 1 week. So it's going to be a bit of annoying when you want to withdraw your money. Especially if it's your rent or something like that. Now on Starknet, the finality is about 2 hours. And there's on layer 2 finality, so on Starknet, it's only 3 seconds. So on Ethereum, the finality is roughly about 2 hours, and on layer 2 Starknet, it's 3 seconds. Now, regarding TPS, everybody likes the term TPS. It's the best metric ever to measure any network. I don't think so. But we reached TPS of 47.29, somewhere there. And basically, TPS doesn't tell you much. Like on Starknet, we have something called multicall, where we bundle a bunch of transactions into a single transaction. And that's counted as 1 TPS. So on Starknet, it doesn't really reveal a lot. That's why we have multiple user operations all wrapped into a single transaction. We're going to see more about multicalls in just a second when we reach the smart wallets. Now, a better metric to use to measure the network is user operations per second. And we can see that we reached 238 user operations per second. Pretty cool. The charts are available on Voyager if you go, and you can check, or starkscanner.com. So, wrapping up, why Starknet? It's heavily optimized for ZK technology or ZK circuits. You get a lot of computing power and reducing the gas fees. So basically, I think we're mostly the cheapest L2 out there right now. It's under 1 cent a transaction. So that's quite cool, thanks to the Denkun upgrade. It's secured by the Starks protocol, and it's built on top of Ethereum. So this means that we inherit its decentralization, security, and transparency from Ethereum. We have a powerful programming language, hence Cairo. It's a battle-tested technology, so it's been running for at least 2 years and has been over $1 trillion in terms of trading. We have StarkX, that's the scaling engine for perpetuals and trading, and we have Starknet. Withdrawing assets to L1 is roughly takes 2 hours. And finally, the most important thing, you don't need a trusted setup. Okay. How are you guys doing? Temperature check? Good?
Maybe there's any questions for now?
I'll take a sip.
No questions? And anybody knows what is ZK? ZK proofs?
We call it magic math, moon math.
Sorry, what is a trusted setup?
So yeah, trusted setup. So basically, if you want to do the proof itself, initially you have to form a trusted setup. And to form a trusted setup, you have to establish some certain parameters in the beginning, and you have to define these private inputs. And only after that you can perform the proof. And the thing is with trusted setup is you have to be very careful of these parameters. Otherwise, if you're not handling them correctly, and maybe it's leaked or breached or whatever, the whole the whole setup is broken, and then that is going to cause a lot of problems. Okay. My hands hurt. Okay. So no break, or you have a question? Yeah.
Thanks. So just if I understood correctly, if you want to use a Starknet, it's basically to have a proof of whatever program you want to execute to save and like use blockchain, obviously. But that's kind of the main point, right? It's like you want a proof of something, and it's going to save energy and money, kind of, right?
Among a lot of things,
okay.
yeah.
Do you have other example, maybe?
Okay, so other examples why Starknet. So first is scalability and cheap transactions. The second one, I would say the technology itself. So there's a lot of improvements in the performance of Starknet. Third, I think we have quite a nice gaming narrative. So if you are interested in on-chain games, we have something called Dojo Engine that is basically a bunch of programs written in Cairo that allows you to create autonomous world and on-chain games. And this is where the power of Cairo comes into play. It allows you to derive things and build your own set of libraries. So Cairo is another important aspect of it. And there's a thriving community and a lot of innovative ideas. So once we're gonna reach the privacy part as well, then you can create interesting applications like layer 3 applications or something called app chains that you have individual layer for your service, and you can change all the settings of your own layer or own block. You can make smaller block time, or you can change the consensus algorithm. You can basically customize anything you want. So to wrap it up, the technology is quite amazing. There's a lot of innovative ideas in the industry, and it gives you the possibility to develop a lot of things.
Wonderful, thank you very much.
May I add something real fast, real quick? Just to give you an idea of like what is super amazing with Starknet in particular, because you have also a lot of L2 that have an amazing like computation power. Like another like a very particular thing to Starknet is a kind of abstraction, is native kind of abstraction, which provides a much better UX, like one of the biggest barrier to entry when it comes to crypto, to blockchain, is a UX. It's super tough. Like you need to have EOS. Like EOS is like an external wallet that you have to basically a MetaMask. So you have to hold your private key. It's super annoying, those kind of things, and it's super tough to require people to know a seed phrase, to hold the key. It's a lot of responsibility for somebody. So it's this part by itself is very hard to handle. And native kind of abstraction allows to get rid of this, not getting into technical details because we could do it, but it's not interesting for like the explanation. But technically, you would never feel the blockchain experience throughout your journey. So basically, anybody could have an account and just not know it's crypto. And basically your private key, you could have your private key, so basically your private key is your wallet, not having to write down a phrase, but you could set up any condition you like to recover it. You could set up like a Face ID if you like. You could set up a lot of those things. So that's very, very cool. You also have Paymaster, which allows you to basically pay with another token than the native token because if you pay in Ethereum, in ETH, you have to hold ETH to pay the gas fees. With native construction, you can decide to pay with another token than the native token of the blockchain. So in terms of UX, native construction is a very game changer, and it's only on Starknet at the moment.
Yeah, correct. Native account abstraction, that's why we have smart wallets, and we'll discuss that in just a bit. So native account abstraction comes with a lot of powerful things, and I'll talk about that in just a second. I think you have a question.
Yeah, thank you very much. I just wanted to know, is there a specific reason why you don't want to focus on privacy right now? Is it for a technical reason or for a legal reason?
I think it comes down to if you're focusing on privacy, then you miss a lot of things on the performance side. So you hide a lot of things, and then developers cannot develop as efficient as possible. And mainly is just we're trying to make a very performant layer 2, and only after that we'll focus on privacy. I think some of people from Starkware actually mentioned that adding privacy on top of it, it's very simple, but creating a performant layer 2, it's much, much difficult. So that's the main reason, is we're trying to scale Ethereum, make it faster, and I think you can, if you want to, you can create it by yourself, the privacy part. So we have the stone prover, you can take that, and then you can create some interesting, almost private application.
Yeah, I think you can correct me if I'm wrong, but most blockchain, they prefer to start with on public, so the data is public, but then on top of that, you can add privacy. So that's the ZK proofs, zero knowledge proofs. And if you guys don't know about, we can talk about it later. It's a huge subject in blockchain right now, and it's basically to create privacy. So I will just ask a question from the chat. So it was the same question. Starknet is not designed for privacy, but is there a way to implement private transactions on Starknet theoretically? And also, can you talk about the current state and decentralization for Starknet and the future roadmap?
Ooh, there are a lot of things to unpack from there. So privacy, first things on privacy. So there's work on this. If people are aware of Cairo 0, there were something called hints that would allow you to inject private data into ZK circuits. So there's already a company working on hints for Cairo. And this will basically allow you to create inject private data in your application. On the privacy part, you can also work with the Stone Prover. It's open source. It's currently written in Cairo 0. We're working on Stew. The naming it's a bit weird, but it's Stone 2, Stew for short. And that's going to adopt the new proving system, the Circle Starks. And you can also create some sort of privacy with that. Now, what was the other question regarding the roadmap, or?
Yeah, the future question was regarding the future decentralization and the roadmap.
Got it. So future decentralization, I guess you refer to the sequencer itself. So currently we have only one sequencer that's currently on the Starkware side. It's centralized, but we are working on decentralizing the sequencer. It's a very complicated job, and we have a lot of good expertise on this, or expert team that are working on this and implementing consensus mechanisms and all sorts of things. So we're working on this. As ETA, I don't know, but we're working hard on this. So yeah.
Hi, can you explain more about how Starknet is safe or safer against quantum attacks?
Safe compared to what?
I don't know.
Okay, so you have quantum, we have quantum, where is it? Anyway, I don't think I can go fast. Oh, here. So we're quantum secure. That's one thing that we're safe of. Then we have the programming language Cairo that ensures type safety. So if you code your program well, you're sure that nothing can happen. Like, for example, if I define my variable as unsigned 256, I'm sure, or unsigned 8, for example, I'm sure they cannot overflow and underflow because it comes with type safety, and I can protect that. So overflow means that it will go out of range, right? So unsigned 8, I think it can have maximum 256 values, or integer can store. And if you go over it, it's going to overflow, right? So with Cairo, you have type safety. You can catch these errors. And it's also a powerful programming language that ensures the security of your smart contract that you're developing. So I would say we quantum secure. The Stark's technology has been battle tested so far. This is already working for 2 years, and it's handling a lot of transactions, and has been used by great projects such as Immutable X, DYDX, and so on. Okay? Cool.
I understand the concept of the proof, but what exactly is reading the proof? Is it the L1 blockchain, or is it the prover on the L2, you know?
Yeah, we'll talk about that in, I don't know, I think in the next session, but basically we have a smart contract solidity verifier on L1, and that reads the proof, and then all the validators are picking it up and validating it. So on L1, there's a solidity smart contract that sits, that's being sent to from Starknet, the sharp prover, and that's being validated, and validators are picking that up. But we'll touch about that, we'll reach about that in just a bit. Cool. Now, no more questions. I have to finish this, otherwise I'll keep you here until 10 o'clock. Joking. If you have questions, feel free to. Let me go back. So, smart wallets. Okay, so what are smart wallets? Do you guys know? No? So, you heard about this term account abstraction, but basically, smart wallets, it allows you to, you can do a lot of things with it, right? So, for example, you can sign a transaction with Face ID or Touch ID that's coming from your phone. You can execute multiple operations in the same transaction, something called as multi-call. So you bundle all the transactions together into a single one, and then you just execute and you're done. And on Starknet, you have to think about wallets that all of them are smart wallets, right? So we don't have EOAs, externally owned accounts like Ethereum. We only have smart wallets. And this is all built by using account abstraction. So the Notion account abstraction, we support it natively since day 0. And we'll see in just a bit what we can do with it. As wallet providers, we have Argent and Bravos. So maybe you have heard about them. One cool thing about it is that you want to install one of them, because at the end of the session, we're going to have a SPOC, more like an NFT. We call it SPOC. It's Starknet Proof of Kudos, and it's going to be a nice badge of you attended this Basecamp. So you can claim that with your either Argent or Bravos. So make sure to install one of them by Friday. Okay, so let's see complex interactions. So basically, sometimes an action requires multiple steps. So if you're familiar with the blockchain and if you traded something, what happens is that, let's say we're trading on Uniswap, you first have to approve the use of token. So in this case, I'm using USDC. And then, only then, I can actually perform the trade. So basically, this is an operation that requires only one action. So we have two transactions, two operations that should be one action, right? And in terms of UX, it's kind of like tedious. If you try to have another person outside of the blockchain, they will say like, well, I have to first approve it, and then I have to first then trade it, and it's a bit complicated. So we have step 1 and step 2. Step 1, approving the token. Step 2, doing the trade. Now, you might think that once you do that, your transactions are going into the same block, and they're in order. So if you do one after the other, you think that, oh, okay, in the block it's going to be approving the token and then trading the token. And then after that, other transactions are coming. But the thing is like you don't have control on how things or transactions are coming into block. And that creates a little bit of an issue. So what we are seeing here is that between your transactions, maybe another transaction has been inserted, or maybe your transaction is another block. So the first transaction is the first block, and then the second transaction is then the second block. And this kind of like opens to an economic attack. Do you know which is that? The economic attack? Yeah, sandwich. So if you're hungry, think about sandwich attack. So sandwich attack is basically, maybe there's a malicious party that inserts his or her transaction between the two, and it does something maliciously. And this is the sandwich attack, also called MEV, maximum extractable value. And this logo basically stands for flashbots. It's a well-known protocol on Ethereum and tries to help with this issue. So that's what's gonna happen. Like in the first block, maybe the malicious attack is gonna be between your transaction, or in the second block, maybe it's on the top of your second transaction. Okay, so sandwich attacks, it's an economic attack on the block. Now, with multi-call, well, good thing, it's like we can fix this, right? So what we're doing is we're bundling the two transactions together, and we're inserting them in the block as intended. So you can be sure and certain that the way you operate it, so you approve the token, and then you did the trade, it's gonna be in the same format on the block as well. No sandwich attacks or no nothing. So we won't have that on Starknet. Obviously, this doesn't protect you from all MEV's attack, right? So there's also the front running, but we cannot protect you on front running. But currently, you're safe because the sequencer is centralized and things are going in a first in, first out. So there's no really front running as of now. Once we introduce a fee market on Starknet, then the front running will be possible. But it's good to know that we are protected from sandwich attacks, and this is one of the powers of multi-call as well, besides bundling a bunch of transactions and making all things simpler. Okay, so account abstraction. What it does is basically it decouples the signer from the wallet or from the account. And the signer is basically the device that you're signing the transaction. So this can be your secure enclave on your mobile phone. And it's usually identified by a private key. And the account is basically the smart contract on Starknet, which has all the logic implemented. It holds the assets for you, and it's also verifying the signature. And it could help, so by default, it executes the transactions with multi-call, but basically what you can do with an account, you can create all sorts of new features. And we'll talk about that in just a second. So to remember, what happens here, we're decoupling the two things. So we have the signer, and then we have the account, and every signer has an account associated with it, right? And now the fun part begins, because now if we have this decoupled, you can create interesting things with the account itself, because basically that's a smart contract, and smart contracts can be coded as you want. So let's see how this looks in practice, and kind of like a high-level overview. So we have your mobile wallet, that's your signer, and on Starknet you have an account contract that is associated with your signer. Then each account contract follows a SNP6 interface, which is basically Starknet improvement proposal, similar to EIPs on Ethereum. And this is basically an interface that every account has to follow, and it has executes, validate, and is valid signature. So is validate signature, validates your signature. Okay, now, on Starknet, there's also target accounts. So for example, if you want to communicate to another smart contract or another account, let's call that target account, target contract. And let's see how this works. So initially, with my signer, I'm just invoking the smart contract or the account contract, and then the account contract will validate my signature, and then if this signature is valid, it's going to continue and going to run the execute function, and it's going to execute to the target contract. So whatever I try to do, maybe send funds, it's going to execute the transaction, and it's going to send on my behalf to the target contract. And all of this, every signer has its own account contract, and it's associated with it. Okay? So signature verification. It allows you to create programmable logic on the account, and it enables a bunch of features. So we have single signers, what we have now with Argent and Bravos. Multiple signers like multisig, some sort of a native multi-signature. You may have heard about Safe, but the issue with Safe is that not all the decentralized applications support signing with multisig. So if you create multisig on Starknet, you'll be able to support all of them. Hardware signers, where you can sign with your mobile, like as a 2FA. So if you initiate a transaction on Starknet, your phone is gonna say, hey, you have a transaction to sign, and you have to prove it. Social recovery, so you can have your friends and family to act your guardians and recover the account itself if you forget it. And session keys, for those who are familiar with games, for example, it's quite a nice feature. Basically allows a certain application to sign the transactions for yourself, and you can have like a good gaming session uninterrupted by signing the transaction all the time. So what will happen in the traditional on-chain gaming, you move a step, you have to sign. You move a step, you have to sign. So it's kind of annoying, right? So session keys solve that. So once you do a session key, you allow the application to commit for a limited amount of time and for a limited amount of actions and a limited amount of assets. And you can play the game uninterrupted. And there are many more things that you can come up with. So it's free for all. If you have ideas, feel free to implement them. Now, supported elliptic curves. We have the Stark Friendly, which is native on Starknet. We have the Ethereum elliptic curves, and then we have the standard elliptic curves that are being supported. Now, let's see how we can turn your phone in your pocket into a hardware wallet. We can do this with account abstraction and the secure enclave. So basically on your phone, there are two systems currently. So there's the shared system and there's the secure enclave. The shared system shares the processor and the memory with the operating system and with all the applications on the phone, while you have a secure enclave with a dedicated processor and memory to perform interesting things. So random number generator, you can do the crypto key management, hardware signer, and this hardware signer is basically what derives the keychain, the touch ID, and the face ID. Now, on Apple products, it's called Secure Enclave. On Google, it's called Titan M. On Samsung, it's called Knox. And other ARM devices, it's called Trust Zone. And it also applies for laptops as well. Now, this is something that we can use with account abstraction. So we can integrate, we can use this as secured enclave and create a hardware signer out of it or hardware wallet out of it. Cool. Now we are reaching a summary here, so let's recap. What we have here is smart wallets allow you to create better UX than regular wallets. You can implement session keys. You can forget about losing your wallet. You can always use a social recovery, and you can implement multi-call, so no more approving the token, trading the token, and a bunch of other things. You can just call it into a single transaction. I think one protocol, I forgot the name, it's either Ekubo or Avenue. What you can do is basically you can create a multi-call and then you can trade from token A to token B to token C to token D in just one single transaction. So that's pretty cool, right? If you want to do some MEV, you know, like extract like some nice profits out of it. Okay, and this is all enabled by account abstraction. So account abstraction basically decouples the signer from the account, and then the account is just a smart contract that you can do programmable logic and implement these features. And it has a specific interface that you have to follow, the SNP6. Also supports signing transaction with different elliptic curves. And one important thing to remember, on Starknet we have smart wallets, we don't have EOAs, right? No EOAs at all. smart wallets. That's the one thing that is important. Cool. Questions? No? Am I that clear? Or is it time for a break? Yeah? EOA? EOA. So it's externally owned account, which is basically the traditional thing on Ethereum. You have a private key and the public key, and these are like basically the signer and the account is together. And if, for example, something happens to your account, like you're losing your private key, it's kind of bad because it like cannot do anything, like it's just gone forever. And it's just, with Starknet, you can decouple, these two are decoupled, and then you can implement the social recovery thing feature, which allows you to recover the wallet without, you know, even if you forget the private key. So with the use of Guardians, I think Argent has it implemented. It's called Guardians, and you can name a Guardian, and that Guardian can help you recover the wallet itself. And it's just a better UX overall. So in gaming as well, we have session keys, and we have a bunch of other things. Multi-call is just already a big thing.
So just to be clear, are smart wallets a specific technology of Keros, or is it technology that you can use on Keros? And are like all wallets on Keros smart wallets, or both coexist?
So one change there, Starknet. So all wallets on Starknet are smart wallets, and it's implemented by using Cairo. So that's how we create a smart contract. You can create an account contract as well. And when you create an account contract, you can define, so if you're following the SNP 6, where is it? So this one, if you're implementing the SNP 6, you can implement anything else outside of it. So if you follow this pattern, it's the standard pattern that you have to build for an account contract. And on top of it, you can create whatever you want. So you have, you can create the session keys that I mentioned. You can create other type of signatures. So you can create the multi-sig if you want to. So you have one or two people to sign a certain transaction. So it's highly customizable. And you can check Argent and Bravos to see what they have in store. They're both different in how they implement things, and they all have different features as well. I think Bravos was lastly, they implemented something called like a daily limit transaction. So you can actually set your account to have a daily limit. And outside of the limit, I think it either gives you a warning or you have to up the limit or whatever you have to disable, which basically on Ethereum, you cannot do that.
So basically, it's easier to interact and develop like a smart wallet on Starknet thanks to Keros.
100%, yes.
Okay.
So smart wallet basically enables you a good UX. We have a workshop on account abstraction, how you can implement an account contract. I haven't included in the presentation, but if you reach out to me, I can send it to you. Like we have a workshop where you kind of like learn from A to Z how to do this with Cairo.
Thank you very much.
No problem. Let's see how we're doing on time. Oh, it's 7 o'clock. You guys are holding up really, really well. 2 hours of no pause. Let's see what we have in store. So I think I have a break here. Do you guys want to take a break? Yeah, okay. Okay, let's take a short break, 5 minutes, and we'll be back in 5 minutes, which means that 7:10. I want you back at 7:10, okay? Cool.
Sorry, if you want, everyone, before going to the break, if anyone wants to go now, tomorrow we will get more in depth and start coding. So no more theory and really practice. and it will be easy for you. Okay.
It's session 3 actually. So tomorrow it's a little bit of theory.
Okay.
And then
session 3 then.
Session 3
Wednesday.
starts with Cairo. Okay, the 5-minute break is done. I know it's short, so if you guys can come to your seats, and we'll start soon. People in the back, are you guys coming or staying? Putting more pressure on them. Okay, I don't know what they're doing, but I guess we're ready to get started. The break was quite short for me as well, but hopefully you got a little bit energized. We have just one part, is the architecture part, but we'll be done soon. So, okay. Architecture 101, and it's not your standard architecture, it's the Starknet architecture. Okay, so let's see what we have here, a lot of things. So, initially, as I mentioned, Cairo is a provable programming language that allows you to create provable programs. The syntax is inspired from Rust, so it's quite similar. And these two things are already things that you know. But the next things are new things. Initially, it compiles down to Sierra. Sierra stands for Safe Intermediate Representation. And then the sequencer compiles Sierra to something called Safe Chasm, right? So this Safe Chasm is also Cairo assembly. And finally, based on Safe Chasm, the proof will be generated. So the steps are like this. You have your Cairo smart contract. You'll compile that on your end, on your machine. That generates you a Sierra file, this safe intermediate representation. That's being sent to the sequencer, and the sequencer will compile down to Chasm, which is the Cairo assembly or the bytecode, and that will be able to generate the validity proof. Now, before Sierra, we had a few issues with this. We had a direct link between Cairo smart contract, and it would compile down to Chasm directly to the bytecode. And this was early days with Cairo 0, and this kind of like introduced a vector of attack. So what would happen is that when you would generate, or there would be a failed transaction included in the block, this failed transaction wouldn't be included because it wasn't included because it could not be handled by the sequencer. So what happens is that the failed transactions are not be able to be included in the block, and the sequencer is not rewarded for this action. So it kind of like opened to a DOS attack or denial of service on the sequencer, and we didn't have any protection whatsoever. So basically the sequencers were losing money because they would have to pay the gas fees, and this wasn't protected. Now with Sierra, Sierra allows us to handle these failed transactions gracefully, and they are included in block. And this basically allows us to have the safe chasm generated and then generate the validity proof. And with Sierra, the sequencers are always compensated. Even if the failed transaction happens, it's handled gracefully, it's included in the block, and then the sequencer will always be paid for this. And this basically solves the denial of service attack. So Sierra introduces this safety between the Cairo smart contracts and the Cairo assembly code. Now, if you remember our small story with the space exploration team, we had this program in Cairo that executes, being executed by the rival country, and then you have the result and the proof from it. Now, to expand on this, to look at the architecture, how the internal modules work on this example, is basically your country has, you have your laptop, you have your Cairo program. Based on your Cairo program, you're gonna generate or compile down to Sierra. You're gonna generate this Sierra file, safe intermediate representation. And you're going to send this safe intermediate representation file to the sequence, or to the supercomputer, sorry. So you send this file to the supercomputer, to the rival country, and the supercomputer will compile it down to this bytecode, the CASM. It's going to run it in the Cairo VM, the virtual machine. And another module, we're going to use the trace from this execution, and it's going to generate the proof, the validity proof. So the module is called prover, and based on the trace of its execution, it's going to generate the validity proof. And this validity proof is being sent back to you, to the verifier, and you can verify this validity proof. So this is kind of like an overview of what's happening. But now let's take a deep dive. Oh, you can get the result as well, I forgot about it. So you get the result of the actual execution. Now let's take a deep dive to how the Starknet module works. So in this similar fashion, you have the laptop, your laptop, you have the Cairo program, you compile this program down to Sierra. You send this Sierra file to the sequencer on Starknet. Then the sequencer will compile it down to the CASM. You run this CASM code. It's being run on the Cairo VM. And then there's another module. It's called Sharp, which is the prover for Starknet. And it's going to generate the validity proof based on the trace. The validity proof is sent to the verifier, which is a smart contract on L1. And this is where the nodes are picking them up, and they verify for validity, for certainty. And you also get back the result. This is how kind of like the whole thing is oversimplified, but to just make it more understandable, in the next session, we're going to take a deep dive to see all these modules independently to see what they're doing. I think in the previous presentation, we see like a complicated thing with a lot of boxes and thingies. That's kind of like the architecture, but this is the simplified version to make a bit more sense. Okay, so Starknet uses smart contracts. Before you're executing a smart contract, what you have to do is first declare it. If your contract is already declared, like an ERC 721, you don't have to declare it again. You can just reuse that contract class, and you can deploy it and basically make an instance of that contract class. Users have to interact with Starknet via transactions, and then transactions must be signed by the user. That's how it works. Now, let's see how declaring a smart contract works. So again, you have your laptop, you have your Cairo smart contract, and you compile it down to Sierra. And then based on this, you have also a wallet that's able to create transactions and sign transactions. So this could be either a Bravos wallet, an Argent wallet, or yeah. What happens now is that you call the declare transaction. In this declare transaction, you're sending your Sierra code or the Sierra file, and this is being sent to the sequencer in the mempool. In the mempool, basically, at one point, the sequencer picks it up, and it will compile it down to CASM. And finally, the question is what we're sending to the prover. Like, are we sending a proof of the compilation of the smart contract? Well, we're not sending a proof, because for this, we would have to have the Cairo compiler written in Cairo, and currently it's written in Rust. So now the question is, like, how do we make sure that the sequencer stay honest and it's compiling the right contract or the right smart contract and not something else? So this is where we're trying to prove compilation. As I mentioned, the Cairo compiler is written in Rust. It's not written in Cairo. And this basically means that we cannot prove compilation. So the long-term solution here is actually to build the Cairo compiler in Cairo, and that will allow us to prove the compilation. Now, as a stopgap solution that we have is basically when you're declaring, you're providing the class hash, or sorry, the hash of the chasm or of this bytecode. So when you're declaring the transaction or the Sierra code, you're also providing a hash of the bytecode. The sequencer gets this, and then it recompiles the Sierra to Cairo. And then at the end, it compares the hashes between each other. And if the hash is correct, we can have certainty that the sequencer is not cheating. So this is how we solve this issue. On the long-term solution, the idea is to have the Cairo compiler written in Cairo. So to illustrate this, sending the chasm hash. So again, we have the same setup as before. We have the chasm that's being compiled as well on your laptop. And then we have the wallet that you'll be able to create the transactions. You're using the declare transaction, and in this declare transaction, you have the Sierra code, but together you have also a chasm hash. And this is being picked up by the sequencer in the mempool, and then once it compiles it, it verifies these two, and this is valid. We're sure that the sequencer is honest. Now, the nice thing about it is you don't have to know about this. It's just the architecture, how it works behind it, right? As the developer, you're just calling the declare function, and you're good to go. But under the hood, this is how it looks like, right? You don't need to know in depth about it, but this is just how the architecture works now. Now, declaring and deploying. There are two different things on Starknet. And initially, declaring a smart contract, what it does, it just registers the code on Starknet. So it registers the code on Starknet, it becomes a class. Oh, yeah. So a declared smart contract is basically known as a contract class. Once you declare it, and it's already declared, you don't have to declare it again. So in case of ERC 721, they all follow the same structure. You don't have to redeclare, redeclare, redeclare. You can use that. And these contract classes are identified by its own class hash. And they're just pure code. So there's no storage associated with it. Nothing, is just the logic itself, right? Now, what happens when you're deploying? When you're deploying, you are actually creating an instance of that contract class. And these are basically derived, like the contract instance is being derived from the contract class. So it's similar in terms of OOP, object-oriented programming. The contract class, the contract instance has its own storage. And it's also identified by a unique address. So this is a unique address that every contract instance you can have. So you can imagine like this. So you have the contract class. It acts as a blueprint. And then you can instantiate multiple instances of that contract class. And you can generate, like let's say we have a ERC 721. And then we generate a bunch of NFTs based on it. So we use the same code, but we have a bunch of NFTs with their own storage and a unique address as well. So declaring is a contract class, and deploying is basically initiating an instance of that blueprint. That's what is the difference between the declaring and deploying. And declaring doesn't have a storage, it's only the code. And deploying, it has its own storage. Questions? Yeah. So if we are sending the chasm code directly, then we're going to have the same issues as with Cairo 0, right? So we won't be able to safely handle or gracefully handle these failed transactions. That's what the Sierra does. It compiles on the sequencer side, and it allows us to protect from failed transactions. And these failed transactions are included in the block as well. And then the sequencer is being rewarded. Otherwise, if we go directly to the bytecode, we have this DOS attack. mempool is just memory pool, where basically all the transactions are. And currently for Starknet, it's a first in, first out. There's not actually like, we don't have a fee market where, you know, transactions are competing with each other, and in this mempool, it's being, the sequencer checks the mempool, it picks up the declared transaction that you sent, and then based on this, it will execute what you did. So it's gonna compile it down, and it's just a place where they live temporarily, and then it's kind of like they pick it up one by one. Cool. Now, we have something called universal deployer. What is this? So basically, this is just a smart contract on Starknet that allows you to deploy other smart contracts. There's only one selector function, and it's called deploy contract. This is what you're using when you try to deploy your own contract. And selector must be invoked with the blueprint's class hash. So if you want to deploy it, you have to get the class hash of the contract class. And then you have to provide the constructor arguments that your smart contract uses. So whatever the constructor function you have to supplement those variables. Internally, it uses the deploy syscall, and this universal deployer is created by OpenZeppelin as a public good, and it's currently written in Cairo 0. Usually here I go to Voyager, and I'm going to show you the universal deployer. It's a cool contract. It's written in Cairo 0, but I don't have my laptop here, so you can check it on your own if you have time, and you can have access to it. It's open source, and basically it's just its functionalities that it deploys the contract instance, and this is because of the whole account abstraction, how it works. Okay, so now let's see the smart contract classes versus instances. So we have a smart contract class. Initially, we declare it. We have to declare. We have to send the Sierra code. And then this is just pure code, nothing else. No storage, no nothing. Now, if you want to deploy or create an instance of this class, first you have an invoke transaction. You invoke this on the universal deployer side, and you call the deploy method in the universal deployer. You also have to provide the constructor arguments and the class hash initially, and then this will create an instance of that smart contract class, and this smart contract instance will have its own storage and its own address or unique address. On top of it, you can also use smart contract classes as libraries. So the same process, you declare it, but now when you invoke it, you can just call library call, and this basically just acts like a library on Starknet. You only use this contract class for its code logic. You don't have storage, you just, if you know, like this contract class calculates something, you just call it and it calculates you something. So it's like a library call on Starknet. So you can have library calls as well, but you also have simple smart contract classes that you can initiate instances out of it. Make sense? Okay, hopefully. Okay, now let's see deploying a smart contract. You have your wallet, you invoke a transaction, and in this transaction you have the universal deployer address. That's the thing that we talked about that deploys your contracts. You have the class hash, so the class that the contract class that you declared initially, and then you have the constructor arguments in your constructor function. So whatever initialization you're doing in the constructor function, that's what it is. It goes to the mempool, the sequencer picks it up, it's going to execute in the Cairo VM, and the constructor is being executed there, and generates a trace out of it. The trace is being sent to the prover, to the sharp prover, I forgot to mention, so SHARP stands for shared prover, and shared because it's shared between Starknet and StarkX. If you remember in earlier slides, StarkX is the scaling engine for immutable X, dydx, and so on. So all of them are using SHARP. And what happens is that the validity proof is sent to L1, to the verifier contract. It's a solidity contract. And you also get back the address of your smart contract. How you invoke a smart contract? The same process. You invoke the transaction, and inside here you have the smart contract address that you created. And then you have the function selector. So for example, get counter or get value or whatever function we created. And we have the function arguments, and then this is being sent to the mempool, executes via the Cairo VM, generates the trace. The trace is sent to the prover, and then the prover generates the validity proof that's being sent to the verifier, and you also get the result back. Pretty straightforward, I think. Or? Cool. Okay, now let's sum it up. Cairo compiles down to Sierra, the safe intermediate representation. Sierra compiles down to safe chasm, or this bytecode. Declaring creates a contract class on Starknet. And then contract instances are basically derived from contract classes. The contract classes can be used as library. It's also important to know they don't have any storage. It's only the logic itself, the code logic. The chasm hash is used to prove the compilation for sequencer, to keep the sequencer honest. And deploying your smart contract requires to use the universal deployer. And there are two different transaction types that we'll cover in the next session in more detail. We have the declare and invoke transaction. And that's it. Woo! Finally. So, it's been a long session. If you guys have any questions, feel free to, yeah. So the proof actually proves the execution of the program. So it just proves that the execution of a program has been done correctly with the correct inputs, and it has the correct outputs. And it also, the execution hasn't been tampered with it. So for example, if you would change something in the code, you would have a different execution hash of it. So the proof basically just proves the whole execution you're certain that the whole execution was valid and it hasn't been tampered with it. Sorry?
If I change the input, the proof will be different?
Inherently, yes. So, but for example, I cannot. Stone prover, there are quite a few examples that you can check. There's a Cairo code in, I think it's a Fibonacci sequence, and then you can actually create the proof based on the Fibonacci sequence, and then you can look at the actual trace generated, which is a bunch of, not bytecode, but it's like logic, and that's something that's being used to generate the proof itself. And then once the proof has been generated, you can use the Cairo verifier to verify the proof that it hasn't been tampered, like the execution and the code hasn't been changed. I don't think, so the inputs are not necessarily private, so you can add them as well. But basically, if you change any parameter or change any code in the whole program, the hash will be different. The proof hash would be different, because you get just a big hash of a proof that you verify this. Does that make sense?
Yeah. Can you see things from the proof, or is it like a hash you cannot see nothing until you know what?
So the proof itself, it's I think it's a bunch of random things, but basically the Cairo verifier is able to interpret this and to verify this. In essence, under the hood, it's a bunch of polynomial constraints, and then this is being verified randomly. I think it's being selected like 4 or 5 points in the whole table, polynomial constraint table. And if these polynomial constraints are valid, then we could be certain that the whole proof is valid or the whole execution is valid. But that's more on the mathematical side, on the in-depth mathematical side, what happens. So once you generate the proof, you're able to put it into verifier, which basically under the hood is just a bunch of polynomial constraints. And the verifier is able to verify those polynomial constraint table. So once you generate the proof, like you need the execution of your program, the execution trace, and with those two together, you can generate the proof itself. And then once you verify it, you also need the program itself. And then together with the program and the proof generated, you're able to validate the actual result of the proof, if it's valid. But in more detail, I think you can go to the Cairo white paper and the Stark's proof system that will kind of like explain in detail how all this process works. Okay? Okay, no problem.
I'm not sure to understand how is the result linked to the proof.
Sorry?
How is the result linked to the proof?
How is the result? So basically, the result is generated. Once you do the execution, it generates the result, but it also generates the proof itself at the same time.
Yes, but how do you prove that the result, the sent result, is
okay, so
a trusted result with?
Got it. So basically,
proof?
like the result, in the end, it's being part, like it's being compiled or being part of the proof itself under the hood. But in detail, I don't know exactly how that works. But once you generate the proof, the code it's inside the proof, the outputs as well, and then this is under the format of a big hash that you have to verify. Exactly how that's verified with the Cairo verifier, I don't know, but if you want, I can send you more information about that.
Is it possible that a transaction can be validated on Starknet network, but not on the Ethereum network? And if yes, what happened? Like we can revert the process?
Good question. I think it's possible, but the chances of that is extremely low, like it's 0.000 whatever. But what happens is that then there's a whole reorg happening on Starknet, and that basically just reorganizes the whole block things. But exactly how that works, I don't know.
Yes, because if I send some token to another guy, when the other guy will receive those tokens, will be defined, the time that will be tagged is defined by the Starknet network and not by the Ethereum validation, right? Like you don't wait to have the transaction to be validated on Ethereum to process to the transaction.
So all of this, what happens is like you send the validity proof to Ethereum, and then once that's valid, we're gonna see next session. We also have the state difference, so the state diff, the data availability, where we store all the differences between these two things. And from the state difference, you're able to reconstruct the whole Starknet block from the last point that it was put there. But basically, one like if the valid is not correct, like the proof is not valid, I believe it's a whole reorg that's happening on Starknet, but I'll have to check in more details to see it.
Thank you.
I hope you didn't answer that question already, but what's the idea behind having like multiple steps for the compilation? Like, what does exactly the compilation between Sierra and I forgot the other name.
Chasm. Chasm, right? Or?
Yeah, thanks.
So basically allows us to decouple the I think I have to go back a lot. So anyway,
No worries.
it decouples the Cairo code and from the Chasm, and we'll be able to improve these modules or things independently without one depending on each other. So this is one essential thing. The other one why we need the safe intermediate representation, the Sierra, is to generate this safe chasm, which basically allows us to trust that every transaction that being submitted to Starknet will be included in the block. So in case of the failed transactions, this will also be included in the block, and they will be handed gracefully. And the sequencer won't fail, so they won't be able. They will be compensated for these type of transactions. Before this, we didn't have Sierra, which basically opened the door to these denial of service attack. The sequencers weren't paid for failed transaction, and then you could see that this kind of like generates a problem because some sort of malicious actor could target the sequencer, and then the sequencer becomes unprofitable, and the transactions are not being covered. So Sierra helps to generate this safe chasm, and it also helps us to decouple the Cairo program from the chasm itself, and we'll be able to work on them independently without them being intertwined.
Okay, perfect. And if I may, I just have a last question. What exactly happens when the transaction has been verified and completed on the Starknet part with Ethereum? I'm having some trouble to understand, like, what's the end of the transaction? What's happening on Ethereum?
So basically, when you generate the proof, you also have the state difference, but first you send the proof to the layer 1 verifier, which is a smart contract. It verifies the validity of it. And once this is valid, then the state difference is sent to Ethereum on another contract, and your Starknet state is being updated. So that's kind of like the end goal. So this is previously, before the Dencon update, this was the data availability thingy, which basically costed more than 90% of the transaction fee. But now with the Dencon upgrade, it's much cheaper. So I think in the next session, we'll cover more in depth how the whole transaction lifecycle works in the Starknet architecture. And basically what happens is that transactions are being bundled together or sent to Cairo, to the Cairo VM, to the sequencer. The Cairo VM executes these, generates a trace. The trace is sent to Sharp. Sharp generates the proof out of it. Proof is sent to L1, to the verifier. If the verifier says, okay, this is good, then the sequencer will send the state diff to another contract on L1, and then the state of the Starknet is being updated. And in the bigger picture, we have also full nodes that communicate with the L1 and Starknet, and with the full nodes, you're able to reconstruct the whole state of Starknet. Even if something happens to Starknet tomorrow, you'll be able to reconstruct it from zero.
I have a question about the Starkware bridge. I don't know if it's you, but I think you said that the finality was about 2 hours, and the bridge it can take up to 8 hours, right? Or I don't know if it's that amount or.
It was the case a few months ago, so
okay.
Now it would take roughly about 2 hours. So
okay.
To withdraw your assets from layer 2 Starknet to Ethereum, it will roughly take 2 hours. So
okay.
It was the case with 8 hours a few months ago, but
okay.
We made a lot of improvements in performance and all the bridge itself.
Okay. Okay, thank you very much.
It doesn't take you 1 week as optimism. Cool.
Are the software used for the other compilation steps are all open source and I can like execute it in my own computer?
Yeah, the Cairo VM is open source. It's written in Rust. I think it was written by Lambda class, and yeah, I can link it to you if you want to.
Okay.
So you can check for the Cairo VM, and it's open source.
And there is only one implementation, or it's like later it will have like more implementation, or like is there like a roadmap for like other people doing like more alternative way, or like it's only stock way of developing this?
So, so the Cairo roadmap, we have a bunch of things on the roadmap. I can show you maybe in one of the sessions what we're planning to build. But we're going to have support for Cairo native, which basically allows better performance on Starknet. But the Cairo VM was written by Lambda class, which is an external company outside of Starkware, and it was basically rewritten from Python to Rust. In the future, yeah, like if people want to develop their own VM and run it, sure, but currently I think it's being developed and maintained by Starkware and Lambda class. But if you want to participate in developing it and you have like PRs or things like this, improvements, you can even propose your own improvements and probably even get rewarded for these actions. Okay?
Okay, thank you everyone. Thank you. So thanks for attending this first session. We will be there tomorrow, same time, for 4 days. Yeah, so I hope it wasn't too deep, and we will try to make a little bit more practice with simple code in Cairo. Yeah, thank you everyone.
Thank you.
Yes, stickers at the entrance.